All right, welcome. Today, we are tackling a big one, a famously weird and honestly, a truly mind blowing topic quantum theory. We are going to take a journey all the way down to the very foundation of reality itself.
So I want to start with a question, because it gets right to the heart of what we're talking about. Is the world around you a completely smooth, seamless thing? Like a painting that you could zoom into forever and it would never lose its detail? Or is it more like a digital photo, where if you zoom in far enough, you eventually see that it's made of tiny individual pixels? Just keep that in the back of your mind as we go. You see, to even begin to understand the quantum world, the first thing we have to do is accept a really strange idea. The universe seems to play by two totally different sets of rules. There's the rule book for our world, the world we see and touch, and then there's a whole other one for their world, the world of the unimaginably tiny.
And this really gets at that divide. The physics that perfectly describes how to throw a baseball or how a planet orbits the sun just completely breaks down when you try to apply it to a single atom or an electron. For that scale, you need a new, much stranger instruction manual.
So let's just leave our comfortable, predictable world behind for a few minutes. We're going down, way down, zooming past what we can see with our eyes, past molecules, even past atoms, right down to the fundamental level of reality. Welcome to the physics of the super tiny.
Okay, so what's the first big rule we run into down here? Well, it's this. Reality isn't smooth. It's not continuous. It actually has a texture. It's granular. It's made of tiny, indivisible pieces.
And these little pieces, they have a name, quanta. That's actually where quantum theory gets its name. It means that everything, light, energy, you name it, comes in these tiny, discrete packets. You can have one packet of energy or two packets, but you can't have 1.5. It is the absolute smallest unit of anything that can exist.
So think back to our first question. The universe isn't a vector graphic, something you can scale up infinitely and it always stays perfectly smooth. Nope. It's more like a pixelated image. If you zoom in far enough, you'll actually see the individual building blocks. Our universe is fundamentally high resolution, but it is not infinite. Okay, so we've established that the universe is made of these little quanta, these reality pixels. That's the what. But the really interesting part, the part that gets wild, is the how. How do these tiny packets actually behave? Well, their rulebook is where things get truly bizarre. So now we're cracking open that playbook for the quantum realm. And I'm going to warn you, pretty much nothing in here is going to feel intuitive. And it's not supposed to. These are the rules for a world that we can never, ever directly experience. We're going to look at 3 of the most famous, most mind-bending rules in this playbook. First, this idea of the two-faced particle. Then we'll get into what I'm calling the maybe state. And finally, we'll talk about a strange, spooky connection that seems to defy all logic. First up, wave-particle duality. Now, in our world, right, something is either a solid object, like a little ball, a particle, or it's a disturbance spread out over an area, like a ripple in a pond, a wave. It's one or the other. But in the quantum world, an electron can be both at the exact same time. It's a single point, and it's also spread out all at once. Next, we have superposition, or what I called the maybe state. Okay, imagine a spinning coin. Before it lands, is it heads or tails? Now, in our world, we just say we don't know yet. But in the quantum world, that spinning coin is literally both heads and tails at the same time. It exists in a fuzzy superposition of all possible outcomes at once, until you measure it. And that brings us to our third rule, entanglement, the spooky connection. You can link 2 particles so that their fates are intertwined. For example, if you know one is spin up, you know the other must be spin down. But here's the crazy part. You can separate these 2 particles by billions of light years, and the moment you measure one of them, the other one instantly knows and snaps into the opposite state. Instantly. Faster than light. It makes no sense, but it's true. So we have a pixelated reality, particles that are also waves, and states that are just a fuzzy maybe. But there is one final twist to this whole story, and honestly, it might be the strangest one of all. It has to do with us, the observer. This is probably the ultimate question in all of quantum mechanics. If a particle can be in all these states at once, like our spinning coin, what is it actually doing when we're not looking at it? The answer is, well, it's profound.
Before we look, that particle isn't in any single place. It exists as this fuzzy cloud of possibilities. It's just a wave of probability. But the instant we measure it, the moment we look, that entire cloud of possibility collapses into one single definite reality. Our act of observation literally forces the universe to pick a side. So here's the crucial takeaway from all this. At its most fundamental level, reality isn't concrete until it's forced to be. An electron doesn't have a specific position until we measure it. Before we look, it only has the potential to be in a whole bunch of different places.
Okay, let's all take a deep breath and start zooming back out. We've seen the absolute weirdness at the very bottom of everything. So how on earth does all of this strangeness build the solid, reliable, predictable world that we live in?
So let's just recap what we learned on our little journey down. Number 1, the universe is pixelated. It's granular. It's not smooth. Number 2, its default state is all about probability, not certainty. And number 3, the simple act of looking at something, of measuring it, fundamentally changes the outcome. Those are the core rules. And this, right here, is the great, beautiful paradox. Every solid, stable, predictable thing you see around you, the chair you're sitting on, the screen you're looking at, your own body, is built upon a foundation of pure uncertainty. It's all just a seething, probabilistic foam of maybes that, when you get enough of them together, averages out to look and feel solid and real. So I'm going to leave you with this final thought. We started by asking if reality was a painting or a pixelated photo. And what we found is that it's made of pixels, all right? But those pixels are blurry and totally uncertain until we look at them. And that leads to the final, really mind-bending question. If the very bedrock of our existence is that fuzzy and that strange, then why does the world we live in feel so incredibly real? Something to think about. Thanks for joining me for this Explain.